Imagine a time before our sun, before our planet, before any of the familiar celestial bodies we know today. Even before our galaxy existed, the universe was a very different place. The universe was a very different place, a primordial expanse of energy and particles. It was smaller, hotter, and filled with a vast cloud of gas and dust, a chaotic mix of elements. This cloud, called a nebula, was the birthplace of countless stars, including our own. Nebulae are the cosmic nurseries where stars are born. These nebulae are like cosmic kitchens filled with the ingredients for stars and planets. They are vast, colorful regions of space where the magic of star formation happens. Gravity is the master chef, slowly pulling these ingredients together. Over time, gravity's relentless pull causes the gas and dust to coalesce. Over millions of years, gravity caused the gas and dust in our solar nebula to clump together, forming a spinning disk. This disk is the early stage of what would become our solar system. As the disk spun faster, it got hotter and denser in the center. The intense pressure and heat in the core led to the birth of a new star. This central region where gravity was strongest would eventually become our sun. The sun, our life-giving star, was born from this process. Farther out in the cooler regions of the disk, smaller clumps of matter began to form. These clumps, influenced by gravity, started to grow. These clumps would eventually become the planets. Over time, they collided and merged, forming the diverse planetary bodies we see in our solar system today. At the heart of the spinning disk, the temperature and pressure continued to rise. The hydrogen atoms, squeezed tightly together by gravity, began to fuse. This nuclear fusion released enormous amounts of energy, and our sun was born. The sun's birth marked a turning point for our solar system. Its powerful gravity shaped the remaining gas and dust, herding it into a flat plane. The sun's heat and light also began to influence the formation of the planets. In the cooler outer regions of the solar system, tiny dust grains floated through the vast expanse of space. These grains, influenced by the forces of gravity, began to collide and stick together, forming larger and larger clumps over time. This process, known as accretion, was the first step in the creation of planets. These clumps, drawn together by gravity, eventually grew into planetesimals, the building blocks of planets. These planetesimals were small, rocky bodies that orbited the young sun, constantly interacting with each other. Over millions of years, these planetesimals continued to collide and coalesce, merging to form even larger bodies. Each collision added more material, gradually increasing their size and mass. In the region where Earth formed, it was a chaotic time, with collisions constantly reshaping the young planet. The early Earth was bombarded by countless impacts, each one contributing to its growth and evolution. The energy from these impacts, along with the heat from radioactive decay within Earth's interior, kept the planet in a molten state. This intense heat caused the materials within Earth to melt and differentiate, forming the core, mantle, and crust. Section 4, a titanic collision, the Moon's violent birth. Early in its history, Earth experienced a cataclysmic event that would shape its future. A Mars-sized object named Theia collided with our young planet in a colossal impact. The energy released in this collision was unimaginable, vaporizing much of Earth's surface and blasting debris into space. This debris, caught in Earth's gravity, gradually coalesced to form our Moon. The impact also had a profound effect on Earth, tilting its axis and creating the seasons we experience today. Section 5, a blue planet emerges. Life finds a foothold. After the violence of its formation, Earth slowly began to cool. The once molten surface started to solidify, and the thick clouds that enveloped the planet began to thin out, allowing the first glimpses of a blue sky. Volcanoes erupted, releasing gases from the planet's interior. These eruptions were frequent and intense, contributing to the formation of a rudimentary atmosphere. These gases formed an early atmosphere, while water vapor condensed to form the first oceans. The cooling process allowed water to remain on the surface, creating vast primordial seas. Over billions of years, life emerged in these primordial oceans, transforming our planet. Simple molecules combined to form more complex structures, eventually leading to the first single-celled organisms. From simple single-celled organisms, life evolved and diversified. These microscopic entities adapted to their environment, paving the way for more complex forms of life. Eventually, these simple organisms gave rise to all the plants and animals we see today. The journey from single cells to complex multicellular life was a long and intricate process. Earth's journey from a cloud of gas and dust to a vibrant living planet is a testament to the power of time, chance, and the fundamental laws of the universe. This transformation showcases the incredible potential of our planet. The story of Earth is one of resilience and adaptation, highlighting the delicate balance that allows life to thrive. It is a reminder of the intricate and interconnected nature of all things.